Hi everyone. We are the congestion pricing team that looked at congestion pricing equity here in our region. And I'm Shirley. This is Cory. That's CJ, and that's Kiana. So, people love cars because cars are awesome. They give you freedom. They let you hang out with your friends in your very own personal space while going wherever you want, whenever you want. It's no wonder then that congestion is a big problem in pretty much every major city. So this is a picture from the Seattle Times showing an especially bad traffic day from October 2016. On this day, it took over 2 hours to get from Everett to Seattle. So as we can see, we're no strangers to congestion right here at home. So congestion like this not only hurts productivity and wastes everyone's time, but it also causes pollution that's harmful to the environment and to people. Another big problem throughout the US is crumbling transportation infrastructure and lack of money to pay for maintenance or improvements to that infrastructure. So this is a section of Interstate 10 in California that collapsed after just some heavy rains. Okay, so tolling though is one possible solution that can solve both of these problems. Tolling makes it more expensive and therefore less desirable to drive, therefore reducing congestion. And tolling also generates money to supply services such as infrastructure improvement and maintenance. One increasingly popular type of tolling is hot or high occupancy toll lanes. And what these are is that they're lanes that allow high occupancy vehicles in for free, but apply a dynamically set price to sell the remaining space in the lane to single occupancy vehicles, all while maintaining performance, which in practical terms here means maintaining speeds of 45 miles per hour or greater 90% of the time during peak periods. So in particular, we're investigating the hot lanes on 405, which run both north and south between Bellevue and Linwood, as shown in red here. So these lanes were put into place in 2015, with tolls ranging from 75 cents to $10, and they're in effect from 5 a.m. to 7 p.m. every weekday. Demand is so high for these lanes that the tolls routinely hit the $10 maximum and just kind of stay there through rush hour. Okay, so what happened to congestion after we implemented the hot lanes in 2015? So here on the y-axis, we show travel time in minutes, and on the x-axis, we have the time of day in hours, so going from about 10 a.m. to about 8 p.m. And these two blue curves show the average travel times throughout the day, going northbound from Bellevue all the way to Linwood, in the untolled, or what we're going to call general purpose lanes from here on out, before and after the hot lane implementation. So what you can see from this is that there was really no increase in congestion as measured by travel times in those GP lanes after the hot lanes were implemented. But you can also see easily that after implementation of these hot lanes, there were significant average travel time savings if you chose to travel in those hot lanes compared to those GP lanes. During the worst average traffic of the day, you could save approximately 30 minutes, for example, going from Bellevue to Linwood. So those were average travel times, but averages don't always give you the full picture, as you all know. So we went through our travel time data set for 2018, and we looked for one of the worst traffic days. So this is one of the worst traffic days going southbound from Linwood to Bellevue, and on this particular day, January 11th, you could have saved almost an entire hour by getting into those hot lanes.
So aside the benefits that Shirley mentioned, we should admit that most of the people, if not all of the people, hate tolls. And the fact that these lanes are commonly referred as Lexus lanes, which means that only higher income individual can use them and can get benefit from them, get us to one of the most debatable questions in the context of congestion pricing, which is whether or not congestion pricing is equitable. So our group tried to answer whether or not toll lanes on I-405 is equitable by answering some sub-questions that are relevant in this context. So the first question that comes into mind is that who are the users of these hot lanes? So this is relevant, but if if we want to think about it more in depth, and in the context of the equity, we realize that the better question would be who gets the overall benefits. So going back to the notion of the Lexus lane, maybe the higher income individuals are the ones who are using these lanes more often, but maybe their usage somehow subsidize the system for the lower income individuals to use it when they really need to use these lanes. So the other factor that we should consider is that all the drivers still have the option to use the general purpose lanes, which are the free alternative to the hot lanes. So that gets us to the next question, which is who benefits per trip. So the logic behind this unit of measurement is that similar to any other economic goods, we can say that we can say higher income individuals can buy them in larger quantities, and that doesn't make those goods basically not equitable. We are also interested in the benefit per usage, or in this context per trip. So to answer the questions that we have used multiple data sets. So the first data set that we have used is the data on the speed and volume of the hot lanes as well as general purpose lanes. So this data is used for calculating the travel time savings and travel time reliability, which CJ is going to talk about it in depth, and they are from the loop detectors along the corridor. The second data set is provided by the Washington Department of Transportation. So this data set includes the trip data of the toll users in 2018, and it has more than 16 million trips. Each of these trips includes the time of entry, time of exit, amount of toll paid, also a unique trip ID, which using these user IDs, we associate each of these user IDs to addresses. To de-identify the addresses, then the addresses are assigned to lower resolution geographic unit, which in this case was census block groups. So this picture shows a map of census block groups in the studied region. So basically, the census block groups are smaller than neighborhoods, and you can see in this map they are color-coded by the average household income. So the last data set that we use is the socio-demographic information about the census block groups, which are basically provided by American Community Survey. This data includes the number of households, the population, and income for each of these census block groups.
So this data set requires some really interesting methodological challenges. And unfortunately, we won't be able to get into the granularity of these methods, but we'd be happy to talk about it afterwards at the reception. But essentially what we do is we start with the trip level data, and we group those by the census block groups that were identified in the hot lane records. And then we also take that socio-demographic data that Kiana was talking about from the census, and we use a method called ecological regression. Because essentially the problem is we're trying to infer individual level characteristics from aggregate measures like census block groups. So we use ecological regression, which is often used by political scientists. The political scientists often use ecological regression to try to estimate individual level voter data from aggregate measures like state level data. So this essentially grants us the ability to look at an individual level income effect on variables of interest. So going back to the question that Kiana posed of who uses the hot lanes, this is kind of the first defining question. It's kind of the Lexus lane question. And if we use that method and plot income on the x-axis and the average trips per household on the y-axis, you can see that the average trips per household increase as income increases, meaning that higher income households are using the hot lanes more, which makes some intuitive sense. When you're looking at the 20th percentile income for the King and Snohomish counties compared to the 80th percentile income on this graph, you're seeing a 148% increase in usage. But it is worth mentioning that most of the households in the system are not at that really high income level. This graph is showing users across the facility, but it is worth noting that the people all along the higher income levels are using the facility at a lot larger level, but the users themselves, almost 80% of them earn less than $200,000 a year. So this kind of leads to the question of who benefits. And because we're data scientists, we naturally want to quantify this, and we do that using a kind of intuitive way, looking at travel time savings and reliability. And we like to visualize travel time savings and reliability by seeing a commuter who needs to be at work at 9 a.m. And they know their commute, it takes 30 minutes, but they also know that their commute can be variable. So they leave 15 minutes early to get to work on time 4 days a week. And that's what we use for these two measures. Reliability is essentially the variability in your commute time and that buffer time that you build into your commute, where travel time is the explicit time it takes to get from point A to point B. And now we want to go to our central goal of essentially making a net benefit measure for each trip. And the way we do that is by trying to put a value on this time and reliability. We take all of the factors that go into a decision-making process when you're driving in the general purpose lane and deciding whether or not to go in the hot lane. A lot of these things include toll, time savings, reliability, and some other factors like GP speed and volume and trip factors, which are those kind of conditional factors that you're seeing in the moment. We put all of these things into a model that shows how people use the hot lanes and when they use them, given the tolls and the benefits that they are provided. And from there, we get a value of time and reliability. Across the corridor, we can see that this value of time is around $53 an hour, and the value of reliability is around $26 an hour. So to put this in perspective, if you were on that really bad day in January 11th of 2018, you'd be willing to pay up to $56 an hour to save that 1 hour of travel time in the hot lanes. So now we kind of start accumulating all of this to get time savings in a dollar amount for each trip. We take the value of time in hours per or dollars per hour and multiply them by the travel time savings for each trip. And then you do the same exact thing for reliability. And from there, we get the equation for net benefits, which is just the travel time savings in a dollar amount plus the reliability savings and then subtracted by the toll. So this now gives us the ability to answer who's actually benefiting. We know who's using, but like, what are the actual equitable impacts? And if we plot the same graph, income on the x-axis, and this time net benefits per household on the y-axis, you can see a very similar relationship. Basically, higher income households are benefiting more than their low income counterparts, but this also makes some intuitive sense. If higher income users are using the facility more, it makes sense that they're going to be racking up benefits over the year. But now we come to the most interesting question, which is the one Kiana posed, and it's who benefits per trip. And once again, the rationale behind this is just because higher income people can buy more of an economic good doesn't necessarily mean that there are inequitable outcomes every time that they buy it. So we try to normalize by usage and just look at when people are entering the hot lanes, what benefits are they getting? So we're going to do the same graph. X-axis is income and Y is benefits per trip. And we actually see this relationship flip. So per trip, lower income drivers are getting more net benefit, even though overall higher income users are benefiting throughout the year. And Cory's going to explain a few more factors that are affecting this relationship.
So when we first saw this, we were a little surprised. And the thing is, we don't really know why this is happening. There's a lot of factors that could be contributing to this. Where you're traveling to, how often you're traveling, where you're traveling from, what time of day you're traveling, how often you use the system, all these sort of things could impact the pattern we saw there. And it's hard to tease out exactly which one is responsible or if there is a single factor that's responsible. But we do think that one of the important factors that explains that pattern is commuting patterns. And when I say commuting patterns, I'm really talking about two things. The first is which way you're traveling, south or north, and the second is the time of day that you're traveling. So the way the geography and jobs in the region work is that most people travel southbound in the morning and northbound at night. So those are the AM southbound peak users and the PM northbound peak users. There's a smaller group of people who go the opposite direction. So they go north in the morning to their job and come home southbound at night. We call those reverse commuters. And then lastly, there's people who maybe aren't following a traditional commute pattern, and those are the off-peak users. So they're traveling in the middle of the day. So once we've grouped people and trips into these 4 categories, natural question would be, well, how does this correlate with income? And so it turns out that lower income individuals travel more during these peak periods, when southbound in the morning and northbound at night. And we also know that it's during these periods that there's higher congestion, and therefore higher travel time savings and more reliability to be gained. And tolls are also higher, but it turns out that even despite the higher tolls in those periods, net benefits per trip are much higher in the morning southbound and in the evening afternoon than those off-peak users and the people counter-commuting. And so we think that the fact that there's this association, that it's precisely when lower-income people are traveling at a higher rate that the net benefits are highest, we think this overlap does a pretty good job of explaining the pattern that we see, which is that net benefit per trip are higher for lower-income individuals than higher-income individuals. Now, all this brings us back to our original question of whether the hot lanes are equitable. Are these Lexus lanes, or is the picture a little more complicated? So on the usage side, we've shown that higher income households use the lane more, but at the same time, most people who use the lanes are not high income households. There's a large chunk of users who are in the middle income range and use it once, twice, a couple times a year, even though, on average, overall, higher income households are making more trips. On the benefit side, we've seen that the usage pattern, higher income households using it more, translates right into benefits. So because they use it more, they get more benefits. But in that crucial question of benefits per trip, when you use it, how much benefit do you get? It's actually the opposite. Lower income households are getting more benefit per trip. Now, we've tried to argue that that pattern is slightly caused by when people are traveling and where they're traveling, which direction and what time of day. And what's cool is that the tolls are set by route and by time of day. So the exact same variables that impact usage and equity are all the same variables that are being used to set tolls. And so that means that the Department of Transportation has a lot of options and levers when it's trying to fine-tune equity and performance on the system and balance those against each other. I'd like to conclude by thanking all the sponsors that have funded the program, and in particular the Washington State Department of Transportation for their technical support and the data they provided to make this analysis possible. And we'll take your questions. Thank you. Yes.
So the lanes accommodate people that are willing to be told, but also the high occupancy vehicles, right? Did your data include the HOV vehicles, or were those data removed?
So the question was about the high occupancy vehicles. These are people who are 2 or more passengers off peak or 3 or more passengers on peak, and whether those were in the data and if they were, what we did with them. So the answer is that yes, we saw high occupancy vehicles in the data. We could also associate them to census blocks. We're not able to identify what kind of high occupancy vehicle the vehicles we saw were. So the key distinction there is there's people who are carpooling, 2, 3, 4 people in the car, and then there's buses who carry a lot of people, a lot of volume, a lot of benefit there. And so we were not able to distinguish between buses and carpools, which means that it's a lot harder to quantify those benefits because, sure, the bus itself might get there 15 minutes faster, but that's multiplied by the 50 people on that bus, right? And so quantifying these transit benefits is a lot more tricky. We didn't quite have the time to be able to link the transit data to this to sort of answer that question.
Did your data lead to any conclusions about the value of raising or lowering minimum level toll?
So the question was about what would happen, or sort of the potential impacts and the value of adjusting the toll pricing scheme along the corridor. And the answer there is it's really tricky to do those kind of analyses because there's a lot of factors that feed back on each other. If you change the tolls, it impacts the number of people who are in the lane, which impacts the performance of the lane, which makes the lanes more or less desirable, which makes people use the lanes more or less, and it all sort of feeds back and it gets this really hard thing to analyze. And so we have done some preliminary analyses, and we'll be sharing those with the Department of Transportation. We don't have nearly enough sort of confidence in those to really be able to say one way or another what the impact would be of changing the toll pricing scheme. Yeah, so it's really hard to talk about, because we don't have individual level income information, right? And so, maybe you think you're going to save some time, you get in the lanes, turns out you didn't save any time at all, right? There's a negative net benefit. Maybe you are Bill Gates on the way to an important meeting, and your value of time is measured in the thousands of dollars per hour, right? The problem is when you're trying to talk about equity, is if you use a different value of time for each trip, you're basically rewarding people with a higher value of time, and you shift your whole analysis to focus on that group. And so when we're talking about equity, what you really have to do is just use the average value of time across the whole corridor and see how that's impacted, even though you recognize there's a lot of heterogeneity at the individual trip level. Do you want to add something?
But that would maybe overinflate the benefit that you see that lower value to consider it. If you conclude that there's some net benefit, then it turns out that people can't value their time.
So the question was, did we consider, for example, people who just ended up not driving anymore because these tolls got put into effect? So the answer is no. And we really struggled with this at the beginning because we struggled to define what exactly equity is in the first place, and that was a whole 3 weeks of us first being here. And so some economists, if you read the literature, basically say that if you really want to know if a toll is equitable, what really actually matters is, for example, how that revenue is then spent. So you could imagine that you have all high-income users using these toll lanes. They're paying for all of it, but then all of that revenue goes into subsidizing something for low-income people. And if the revenue is used that way, then some economists would argue that that's how you should define equity. So, and then another possible measure is exactly what you bring up, is well, who actually got taken off the road entirely? And we're not able to see those people. So we weren't able to do that kind of equity analysis, and that's why we focused on those 3 really specific questions that we showed. So yeah, we did our best with that.
Great work, everyone. I'd like to hear a little bit more about how the tools are collected, what kind of centers there are, and if there would be a possibility for organization tools for different income users, and imagining that was possible, how would that change your analysis in terms of how you would determine the best allocation of resources?
Yeah, so the question was kind of regarding how tolls are collected, and then the possibility of doing either a low income subsidy for certain tolls and that sort of thing. So that's a very interesting question, and that's also, it kind of led to the policy analysis that we've done, because it is very complicated in terms of, 1, price elasticities for people of different incomes, and then 2, the efficiency aspect and the attractiveness aspect of if you're putting a lot more lower income people into this lane, what are the effects on performance and then like subsequent price elasticity. But it is interesting because I think there's a House bill in committee right now that's kind of trying to address some of those things with a possible subsidy. But to answer your initial question, they do have toll plazas, and they scan you at each of these toll plazas. You set up an account usually, or you can pay by plate. So that solution is definitely feasible, but I'm sure administratively it would be very difficult to administer. But that's something that we definitely explored.